Hello students, welcome to Uncle. Good evening to all.
Good evening, sir.
Good evening to all.
Good evening, sir.
Good evening. So few more questions on various thermodynamic processes. So today we will also discuss the problems related to calorimetry, in which we will make use of the specific heat and latent heat concepts. An ideal gas has a specific heat ratio, that is Cp by Cv equal to 2. Isothermal compression to increase its density by a factor of 2. And after this process, an adiabatic compression the temperature of the gas at the end of the second process would be, means at the end of the adiabatic compression. So two processes are there in succession. First one is isothermal and second one is adiabatic, and both are compression. It means in both of the processes volume is decreasing and the pressure is increasing or the density is increasing, you can say. So in the first process you will have to make use of the density, and in the second process pressure and temperature variations are there. Very good, Kapil. Very good, Mamta. Let me solve alongside. First, for isothermal compression, temperature is given to be T1. So initial, final. Very good, Yashri. So initially temperature is T1. Let density is ρ1 and it is given by m by v1. And finally the temperature will remain same in any isothermal process, and the density is given to be 2 twice. Okay. So it means it has become 2m by v1. It means m by v2, it has become, because mass does not change. Na? So it means v2 has become v1 by 2. Is it clear? So now these are the initial values, na? T1 and v1 by 2 for the adiabatic compression. But it has been given that the pressure increases by a factor of 2 and we have to calculate the temperature. But we are having information regarding the volume. So pressure increases by a factor of 2. Na? Actually, there was no need to solve this.
Yes, sir.
Yes. We could have done it straight away with the adiabatic compression because there is no link with the given volume. Na? Just the change of pressure is there. So we can make use of the equation connecting pressure and temperature. Na? And what is that equation? So initially, let us assume pressure is P1, temperature is of course P1. So here the pressure is P2, which has become 2P1, na? And T we have to calculate. Let the temperature is T2. So equation is P1 1 minus gamma. T1 gamma. This is the equation. This one. So T2 gamma. P1 by P2 1 minus gamma. T1 gamma. So T2 is P1 by P2 1 minus gamma by gamma T1. Is it? So it is 1 by 2. 1 by gamma minus 1. Now what is gamma? It is 2, na? So clearly it is root 2 T1. So no need to solve for this. I don't know why they have given this information. No need to do this. We can cut it short. Na? The only thing we have to remember is in isothermal process, the temperature doesn't change. That is the main thing. Okay. Clear? Please check everyone. Clear or not?
Yes, sir. Clear, sir.
So only second process was required. In a thermodynamic process, the volume of 1 mole of an ideal gas is varied as a t power minus 1, where a is a constant. What is the amount of heat received by the gas increases by delta T in the process? R delta T by 1 minus gamma, R delta T by 2 minus gamma, R delta T 2 minus gamma by gamma minus 1. These are the options. Volume temperature relation is given. Adiabatic exponent is given. Amount of heat received if the temperature increases. It doesn't mean that the process is adiabatic. Otherwise, there is no point of calculating the heat received. Na? Otherwise, dq would have been 0. Na? So, according to first law, dq is du plus dw. So it means we need to calculate these quantities, du and dw, in order to get the heat received. And what is du? Du is Cv dt. Na? And what is Cv? We know that. Let me do it here. For 1 mole of a gas, we know that Cp minus Cv equal to R. Na? And we also know that Cp by Cv is gamma. So can I write Cp as gamma Cv? Therefore, gamma Cv minus Cv equal to R. Gamma minus 1 into Cv equal to R. So Cv is R by gamma minus 1. So therefore, du has become R by gamma minus 1 dt. Or you can write it equation number 2. Du. This is 3, this is 4, this is 5, now this is 6. So we are able to get du na, in terms of the given quantities. Of course, now we can write it as delta T instead of dt. You can put it del T, because in the options they have given del T. So let us write del T. Okay. So now what about dw then? What about dw? In PdV, what is P? PV equal to RT. So P is RT by V, and V is A by T. So RT square by A. What about dV? Because V is A by T, so dV is minus A by T square dt. So now we can solve this. And then we can substitute the values over here to get the amount of heat received. Okay. So it will become A and A cancel, minus R dt. Na? R is constant, minus R dt. So it means minus R delta T. Because it will be the difference of temperatures only. So therefore, from 1 we have. So dq will be R by gamma minus 1 del T minus R del T. So R del T can be taken as common. 1 by gamma minus 1 minus 1. So R del T 1 minus gamma plus 1. So R del T 2 minus gamma by gamma minus 1. This is the answer. D option. Please check. Just based on first law of thermodynamics, nothing special. Done?
Yes, sir.
again based on first law of thermodynamics. But now you need to calculate W, del W. So dq is du plus dw. Na? So it means dw or W, it will be dq minus du. And this is given. Either you can call it q or dq. So this will become 14 joule minus d. Let this be equation number 1. So we need to calculate du only. That's it. Okay. Now the gas is given to be diatomic. Now for diatomic gas, how many degrees of freedom are there? 5.
Yes, sir.
So Cp will be 5 by 2 R. Can I write it directly now? And Cp will be Cv plus R. Like this. Is there any need to get this? We need to calculate. Yes, we need, because we need to calculate del T also. Na? So Q is Cp del T or dq. What is dq? It is Cp dt. Na?
Or CPDQ. Like CPDQ. Okay, but the constant pressure.
Du is Cv dt, but dq is Cp dt. Na? 7 by 2 R. Either you can call it dt or del T. Okay. So dt has become by 7 R. So 4 by R. Na? Let it be number 2. So du is Cv dt. It is 5 by 2 R. And dt is 4 by R. So these two will get cancelled. So du is 10. Na? 10 joule. Therefore, from 1 we have dw 14 minus 10 equal to 4 joule. That is the answer. Okay. And what is this process?
Isobaric.
Which kind of process is this? Constant pressure.
Isobaric.
Isobaric. So now you can note down one shortcut. One shortcut is there with me, which says in an isobaric process, work done in terms of absorbed energy or heat is given as again you are getting the same answer. So you can remember this formula as a shortcut. Clear?
Yes, sir.
A box Let me make the diagram for you and I will explain the question, what they are saying, and then you can try. Have you noted the question, all of you?
Yes, sir. Noted.
Yes, sir.
Yes, sir.
So it is given that there is a box like this, and it is divided into 2 compartments. Initially, the volumes are equal, so these are the volumes, equal volume, and pressures are 3 P naught and P naught, and this is movable wall. Okay, this wall can adjust itself. Obviously, it has to, because the pressure is unequal. So this wall, it will adjust itself so that the pressure on the 2 sides become equal, and obviously it will move towards the side with lower pressure so that the pressure is adjusted. So the final pressure becomes Pf and let the volumes have become V1, V2. And obviously V1 will be greater than V2, na? As I said, because the pressure was greater on the left side. So the pressure has reduced, so the volume will increase. Okay. And initially the total volume is 2V0. So will be the final volume. Na? It means V1 plus V2 should be equal to 2V0 because total volume, it should be constant. Na? It cannot change. Okay. So now you can try. So clearly the process is adiabatic. That's why they have provided you with gamma. And otherwise also only this wall is movable. Na? The system is not exchanging anything with the surroundings. So you can make use of the adiabatic process equation for this one. This side and this side, left side. Or either you can make use of this side and this side because the pressure is same. Na? So now for left hand side, PV gamma equal to constant means 3 P0 V0 power gamma. It should be equal to PF V1 power gamma for the left hand side of the box. And this gives V1 equal to 3 P0 V0 power gamma by PF 1 by gamma. And for the right hand side, I can write P0 V0 gamma, PF V2 gamma. So this gives V2 gamma, P0 V0 gamma by PF. So V2 will be P0 V0 gamma by PF power 1 by gamma. Let it be number 3. So now we can substitute this V1 over here, this V2 over here, and then the whole equation will be in the terms of given quantities. No? That is P0 V0 and then PF. So obviously we can get PF out of that equation. Okay. So now please solve it. Get me the value of PF. So obviously we can cancel this factor of V0 from both the sides. This na. So P0 power 1 by gamma. PF power 1 by gamma. So PF will be P0 power gamma. This is the answer. Na? 3 power 1 by gamma plus 1. This option, C option. Please check everyone. This is the expression for the final pressure in both the compartments. Clear? Is it clear?
Yes, sir.
Yes, sir.
Yes, sir.
Now try this one and give your answer in the chat box. Little bit similar to the earlier one. Now clearly the heat will be exchanged between the two compartments because they were at different temperature, and when we will remove the ball, the heat will be exchanged. Only then the temperature will become same. It means the heat lost by one system should be equal to heat gained by the other system. And for this, you need to suppose either T1 to be greater than T2 or vice versa. Okay? Only then you can solve this question. So let us suppose initially T2 was greater than T1 and the equilibrium temperature is Tf. Yes, Ramjan, very good. Very good, Mamta. Now see, heat lost by system 2 because it was at greater temperature should be equal to heat gained by system 1, and heat lost is Cp2 T2 minus Tf. It will be Cp1 Tf minus T1 Cp delta T. Okay, and if N2 moles were there because different volumes were there, so N2 moles, N2 R gamma by gamma minus 1, because in the last question we proved that Cb is R by gamma minus 1 and Cp is gamma Cb, so it will be R gamma by gamma minus 1. Okay, and for N moles it will be like N R gamma by gamma minus 1. Clear this step?
So why can't we use Cb to
What?
Can't we use Cb directly instead of Cp? Because the body is also like.
Yeah, you can use it here. You can use in this particular question. Yes, not in every question.
Okay.
For this question it will work. So we are left with this term only. R will also get cancelled. So N2 T2 minus Tf, N1 Tf minus T1. So N2 T2 minus N2 Tf, N1 Tf minus N1 T1. So N2 T2 plus N1 T1, N1 Tf plus N2 Tf. So we can take Tf common. N2 T2 plus N1 T1, N1 plus N2 Tf. But now we need to substitute for N1 and 2. And what are N1 and 2? Now we know that PV equal to nRT. So therefore P1 V1 equal to N1 RT1. So P1 V1 by RT1 is N1. Similarly, P2 V2 by RT2 is N2. Okay, so substituting 2 and 3 in 1. P1 V1 by RT1 into T1 plus P2 V2 by RT2 into T2 by. So in the numerator, T1 and T2 will get cancelled. And R, of course, also get cancelled with the R in the denominator. So it will be P1 V1 plus P2 V2 by, let me write, P1 V1 plus P2 V2 by P1 V1 by T1, P2 V2 by T2. So C option. You can check. And here is the shortcut formula with you also. This formula you can remember now. That if N1 moles of gas at temperature T1, same gas at temperature T1, they are mixed with N2 moles of same gas at temperature T2, then the final temperature will be. Okay? Clear?
Yes, sir.
This is you. These superscripts, they denote the system 1 and system 2. Because these two systems, they are put in contact, so sum of their energy should be equal to total energy. It means if we can get u1 and u2, then their sum will be equal to u2 total, and from there we can get the answer. This one. Now, when the thermal equilibrium is attained, the temperatures will be equal, and that temperature is represented by T. And of course, U total, it should be equal to U1 plus U2. Now substitute their values, but put T1, T2 equal to T only. Yes, Divya, it's correct. Yes, Rita, very easy. You can see easily we have got B option, that is answer. Now let us discuss some questions based on principle of. सिर्फ यही easy लगा. Why, Rita?
Yes, sir.
What's the problem with other questions? They were also easy. You just have to make use of ideal gas equation or isothermal or adiabatic. Only these
Yes, sir. बट जल्दी से कनेक्ट नहीं कर पाते.
Yes. A thermally insulated coffee mug.
सर हिंदी मीडियम से हूँ तो थोड़ा इंग्लिश में भी प्रॉब्लम आती
है. Okay. Warm coffee. Thermally insulated means the mug, it will not exchange heat with the surroundings. Mug की heat बाहर नहीं जाएगी और बाहर की अंदर नहीं आएगी. जैसे the one like the thermos flask we use in winters na, to keep the tea or the water hot. Yes, but of course that exchanges heat to some extent with the surroundings. But here it is given that it is thermally insulated completely. But nothing is ideal, okay? But in numericals they can give you just like this one. 1 calorie per gram per degree centigrade, and the latent heat of fusion. Now, first of all, who will tell me the difference between latent heat and heat capacity? Anyone knows the difference?
सर लेटेंट हीट में टेंपरेचर कांस्टेंट रहता है.
तो फिर उस क्या चेंज होता है?
From one state to another state.
Yes.
Gas to liquid, solid to liquid.
First of all, both are heat. Whether it is latent heat or heat capacity, it is the amount of heat. But latent heat, it is the heat required to change the state of the substance at same temperature. For example, water at 100 degrees centigrade to steam at 100 degrees centigrade, or ice at 0 degrees centigrade to water at 0 degrees centigrade. Then the amount of heat required will be latent heat. Okay. But if you change the temperature of the substance, keeping the state same, for example, we are heating the water from 20 degree to 100 degree, then it will be called heat capacity. Okay. Clear?
Yes, sir.
So now have a look at the units. It means this much 1 calorie of heat is required to raise the temperature of 1 gram of this liquid or the coffee by 1 degree centigrade. It means if you have taken 1 gram of coffee and if you are changing the temperature of that coffee by 100 degrees centigrade, then 100 calories of heat will be required to change the temperature. Okay.
Yes, sir.
So the question is, coffee is at temperature 80. Okay. तो उसमें कितनी आइस डालें आप? How much ice should be dropped into that cup कि उसका जो टेम्परेचर है it comes down to 5 degree, means hot coffee becomes cold coffee. How much ice should be dropped into that cup? That's what we have to calculate. So let us suppose we need m gram of ice for this purpose. Now coffee is losing the heat and the ice will gain the heat till their final temperature become 5 degrees centigrade, isn't it?
Yes, sir.
Now heat lost by coffee should be equal to heat gained by ice. This is called principle of calorimetry. Okay, so you can write according to principle of calorimetry. Heat lost by coffee is equal to heat gained by ice. Now it is given by, because coffee remains coffee, it is not changing its state now. It remains in liquid state only, so it will be mc delta T only. Okay, but what is the mass of the coffee? It was 500 gram and heat capacity it is 1 calorie and temperature comes down to 5. Now why I have taken the temperature in degree centigrade? Because this heat capacity it is given in degree centigrade inverse and gram inverse. That's why mass मैंने gram में ही रखा and temperature, because temperature difference will remain same. Even if you take the temperature in Kelvin, the difference will remain same. So there is no point of converting that heat capacity into Kelvin and Joule. Okay, but now first of all the ice will get converted to water at 0 na? And for that ml, m into l is latent heat and that is 80, and then mc delta T, then the temperature of the water, this is for ice at 0 degree to water at 0 degree. Okay, and this term is for water at 0 degree to water at 5 degree. Is it clear? When the temperature changes, mc delta T, when the state changes, ml, l is the latent heat. Please check everyone.
The mass of ice and mass of water is same.
Yeah, mass will remain same, of course. Nothing is being lost now. So now left hand side is 500 into 75. This is 80 m plus 5 m. So 500 into 75 is 85 m. Please solve this and check, are you getting 441?
So that type of problem we did at class 11 standard.
Yes, yes, you are right. And this whole kinetic theory and thermodynamics, it is from 11th class only. The basic lies over there. Clear to everyone? Are you
Yes,
getting? Yeah, but in the option it is only 441. So that's why I have rounded it off to 441. Now one more question, similar to this one. Try to solve it. 10 grams of ice. So try to solve this one now.
So I have answered, please.
It's wrong. It's wrong, Rima. Be careful. Stick to basics while solving the question. No, Tamya. No, Ramdya. You can try this experiment. You can take it as an experiment and you can try it at your home, okay? You can take some amount of water in the glass and then you can keep on adding the ice to it and then see what happens. So according to you, the water will get converted to ice. Is it possible?
No, sir.
No, sir.
When you people are giving this answer, it only means that you are saying that the water will get converted to ice because the temperature is less than 0 degree. And at 0 degree, water gets converted to ice. Have you seen this happening?
Oh, no, sir. No.
So it means the answer is wrong. Na?
Yes, sir.
So then what should be the correct answer?
शायद भी हो सकता है
Sir, 0 degree हो सकता है.
Yes.
Yes, sir. I also did the wrong in this in class 11th standard. I thought that.
Now I will tell you why it is the option. Now see, first of all, when we add ice to water, the temperature of the water will drop from 25 to 0. The first thing will this, na?
Yes, sir. Yes, sir. And then
Yes, and for this to happen, the heat lost by the water is 750. And now let us see how much heat is required to convert the ice into water.
Yes, sir. 800 calorie, but there is 750.
Yes. So to convert ice into water at 0 degree, the heat required is ml. Is ml, which is given by ml is mass is 10. It is 8800 calorie. It means whole of the ice will not get converted to water. Okay.
Yes, sir. A certain amount of
some amount of ice will still be there. It means finally what we have is water at 0 degree plus some ice, isn't it?
yes, sir. Yes, sir.
Let me make the diagram also. So initially we were having some water and the temperature of the water was 30 na? Or 25. What is the value? 25. So now we are adding some ice to it. Okay, 0 degree. And finally what we are getting is again water. Of course you can make some ice balls along with water. But the temperature of the mixture will be 0 only. Na?
Yes, sir.
Now is it clear or not?
Yes, sir.
yes sir
क्योंकि पूरी ice melt नहीं हुई है. In this process we are not having sufficient amount of heat to melt the ice completely to form water. अगर ऐसा होता तो water बन जाता and the temperature जो है हो सकता है temperature 0 भी नहीं होता. It might have been more than 0 ना. But it cannot happen that if you are adding some ice to water then the water becomes ice. This cannot happen. So the temperature cannot be less than 0. Okay, please keep this thing in mind.
Yes, sir.
Now next one, little bit different one, but again based on this heat problem. A metal bullet comes to rest after hitting its target with a velocity if 50% of the heat remains in the bullet. what is the increase in its temperature? So let me make a diagram for you. There is a bullet, okay, and it is moving with a velocity of 80 meters per second, and it hits the target. And of course, some heat is generated. And 50% of that heat generated, it remains in the bullet. And of course, because of that, the temperature of the bullet will rise. So we have to find the rise in the temperature or the increase in the temperature of the bullet because of this. Means delta T. We don't have to find the exact temperature increase, that is delta T. So that's why the initial temperature of the bullet is missing in the question, because we don't require it at all. We can just put the heat retained by the bullet equal to mc delta T. That's it, man. With the help of that, you can get delta T. So first of all, calculate the heat generated, because only then we can get mc delta T, which is half of it. So what is the heat generated in this process? How much? Yes, sir, very good. So how much heat is generated? How we can calculate it?
We can say the kinetic energy. That's only energy.
Yes, because the bullet is having some kinetic energy after hitting the target. It will come to rest. It is clearly given. So it means it is losing its kinetic energy, and according to the law of conservation of energy, that kinetic energy will get converted to heat. Okay, so heat generated, which is half mv square, and now we can calculate it. Actually, I'm not doing the calculations here. I will do the calculations in that. Yes, Mamta, it's correct. So right now I'm leaving it up to half mv square, and it is given that half of it is retained by the bullet only. So heat retained by the bullet, half of half mv square, which is 1/4 mv square. So therefore, mc delta T is equal to 1/4 mv square, because the same heat will increase the temperature of the bullet. Okay, so it means delta T will be v square by 4c, because m and m will get cancelled. Yes, Divya, it's correct. So now you can substitute the values. Speed is 80 meters per second, and what is the specific heat? 160 joule SI units. So it will be 80 into 80. Degree set. C option. So everyone, please check. And you can relate this problem to classical mechanics also. There also they ask these kind of problems, but then this part will be missing totally. So then it will be based on the conservation of momentum also. They can ask you the final velocity of the combined system, that is bullet plus target. And they will give you the mass of the target also over there. Okay. So then by making use of the conservation of momentum, we can get the final velocity of the system. Am I right?
Yes, sir.
The target is fixed, so will it move? The target is fixed.
So not here. I'm telling you about the classical mechanics kind of problems. If the target is movable.
Okay.
Of course, if the target is at rest, then this question is not valid now. Suppose a log of wood is hanging with the help of a thread, and you are hitting the bullet in that log of wood, then that is capable of moving.
Yes, sir. Yes, sir.
Those kind of problems they may be asked. Now, a small definition. What do you mean by isothermal compressibility? Now, isothermal means at constant temperature, and it is denoted by K. Here, T denotes constant temperature, that is isothermal, and it is given by -1/V, curly V by curly P. And we can see this V and V can get cancelled in units I'm talking about, and it only depends upon pressure. And because pressure is an intensive quantity, so will be the isothermal compressibility. Therefore, isothermal compressibility is also an intensive quantity. Okay. Clear? So we will end our today's discussion here. So we will continue tomorrow, and I will tell you about the bulk modulus and some other quantities also. Okay, so now you can try problems based on principle of calorimetry that we have discussed today. So hope we have done enough practice on isothermal and adiabatic. Okay. Okay, students.
Yes, sir.
Any doubt?
Yes, sir, no doubt. But I'm asking that has the total videos of the electricity and magnetism been completed? The portion
Yes,
of
of course. Yes.
Okay, sir. Okay, sir. Okay, just asking.
That's why we started with the next unit.
Okay, sir. Okay, sir.
In fact, we have done that the small optics portion also in that related to your interference and diffraction. Usually that is mentioned in optics part, but because it was related to electricity and magnetism, it was related to the electromagnetic wave, electric field. So I have covered that part in electricity and magnetism only. Okay.
Okay, sir.
Okay, students. Bye bye. Take care.
Thank you.
Bye, sir. Thank you.